All right, so I'm going to use this time in this short video to kind of explain a few more problems from the assignment I gave to you today in class. And this assignment is titled Two-Dimensional Forces Worksheet. And I know I did number 1 and number 2 with you. So I'm going to do number 3 as well. That way I can give you a little more practice. I know that it took the entire period to work on two problems, maybe even 3 for some of the classes. But this video will help you out to kind of put everything together. Okay, so let's read number 3. And number 3 says a free body diagram is shown above. What force F must be exerted on the object so that its net force is 0 at 30 degrees above the negative x-axis? Okay, so it's given us a few information here. We're obviously looking at the free body diagram shown above. So we're going to try to find what value of F we need to exert on the object. And the condition is that the net force must be 0. Okay, and that the angle that's given to you is 30 degrees above the negative x-axis. So if we were to draw a line horizontally, this angle here would be 30 degrees. Okay, so now we know that F can be broken up into two components, and let's find that first. Let's find the components to F. F is equal to, F sub x is equal to F cosine of 30 degrees, and F of y, or F sub y, is equal to F sine of 30. Okay, remember that F sub y is in this direction, and F sub x is in this direction. Right, so for that reason, this angle 30 degrees is adjacent to F sub x. This can also be F sub x. And F sub y is opposite to the angle of 30. For that reason, for F sub y, we use sine, and for F sub x, we use cosine. All right, so you always start off with that, start breaking up the two-dimensional vectors into its components. Okay, so we wrote down the direction, and we must meet the condition. So the condition says that the net force must be 0. So that means that the sum of all forces in the positive x direction plus the sum of all forces in the negative x direction, that must then equal to 0. We can do the exact same thing for the y-axis, and that was for the x-axis, sorry. We can do the exact same thing for the y-axis, that the force in the positive y direction, and that the sum of the forces in the negative x direction, negative y direction, was equal to 0 as well. Okay, so what does that mean? Well, let's look at the x-axis. On the x-axis, if I were to draw a summary free body diagram, which is not a free body diagram, the force to the right is 31 newtons, and that of the left is F sub x. Then downwards, I have 68 newtons, and upwards, I have 2. I have 50 newtons, and then I also have F sub y. Okay, that's the summary free body diagram. That's not how you draw it, though, okay? This is the free body diagram, not that one. That's just to kind of help you understand what's going on here, all right? So on the x-axis, we have to set that the forces in the positive x direction must equal to the forces in the negative x direction, okay? So let's plug in a few numbers. On the positive x direction, I have 31 newtons. So 31 newtons is then equal to the force in the negative x direction, which is F sub x, and F sub x from this first part over here is just equal to F cosine 30, right? So F cosine of 30 degrees. And you're probably wondering, well, sir, we don't have F. Well, that's exactly what we're trying to find, okay? So in order to find F, all we have to do is divide by cosine of 30 degrees, and that there will give you the answer for F. So let's say you wanted to try use the y-axis instead. So remember that the sum of the forces in the positive y direction must equal to the sum of the forces in the negative y direction. So we substitute a few numbers. Positive y direction, I have 2 of them. I have 50 and I have F sub y, and I get that from this picture up here. So if the 50 plus F sub y, that equals then to the force downwards, which is 68 newtons. We don't put a negative because it's like this was a negative number right here. So to just move it over, we added it. All right, so that's why this number is no longer negative. Okay, so then F sub y is equal to 68 minus 50. But I also know that F sub y, according to their equation over here, is F sine 30. degrees. So I can divide by sine of 30 degrees. Divide by sine of 30 degrees. And that will also give me f. So I have two formulas for f that I can use to find it. F equals to 31 over cosine 30 degrees. And it's also equal to 68 minus 50 over sine of 30. And that there is how you would find f. So you can use either this one or this one, and it is completely up to you at this point. Okay, so number 20 is probably the hardest in this one. Let me go back up to this. Number 20 is probably the hardest in this one because you have a bunch of forces. But there are some that cancel out. If they're directly opposite to each other of equal value, they just cancel out. All right, so let's keep moving on. Let's see which other one I believe is a little, not difficult, but useful for the future. You're always going to see two-dimensional vectors, okay? So get used to that. All right, let's see. We can do this one here. It says for each situation below, combine the vectors as indicated and determine the direction of the resultant vector. Then select the closest direction to the resultant from the direction the rosette at right. Okay, so let's do one of these. N plus P plus K, and I'm doing this one right here. J equals to N plus P plus Q plus R. So I do N plus P, and P, if you notice, it goes 2 to the left and 3 up. So 2 to the left, 3 up. So this is P right here, vector P. Then I add Q, 1 to the left. And where do I know? How do I know that? I look at Q right here. So Q, and then plus R. R is 2 to the right and 2 down. So 2 to the right, 2 down. R would be right there. Okay, I know it looks like a mess. So overall, and I'm going to delete all of this right here. Overall, the resultant vector J is from here. Let me see. Let me do this one more time. 2 to the right, 2 to the left, 3 up, 1 there, 2 back. All right. So the vector J is in this direction. Okay. So I look at this picture over here on the right side, and that would be approximately in the direction of H. Okay. So you would have to do that for the rest of the problems. Okay, and for this one as well. Well, for this one, you just have to find the components, but you do have to do the vector addition first and then find the components to it. So let me give you an example, A plus B. So I do vector A, the tip of that one goes to the tail of B. So B goes 2 to the right and 2 down. So B is right here, right there. Then I add C, and C is 1 to the left, so vector C. And I add D to that, so it's 1 up and 3 to the right, 1 up and 3 to the right, 1, 2, 3. This vector D right here. So overall, this here is your resultant vector, and that's your resultant vector K. So the X component of K is 1, 2 to the right, it's positive, and the Y component of K is 1, 2, 2 up in a positive direction. So I'll just put positive so you know that it's right and positive. All right, so I hope this video helps you to figure out the two-dimensional vectors, and I'll see you next time.